Hello, everyone, and welcome to our latest episode of Expert Insights. Today, we've got Gian Marco with us. Gian is an expert on TinyML. So, Gian, why not just start with introducing yourself? I'm pretty sure the viewers want to hear you and not me.
Absolutely. But before starting, honestly, I need to thank you for this opportunity. I'm more than happy to be here and talk about TinyML. I'm Gianmarco Iodice. I'm the tech lead for the machine learning group at ARM for the ARM Compute Library. So if you don't know what the ARM Compute Library is, the ARM Compute Library is a software library developed by ARM to accelerate machine learning routines on ARM processors, in particular Mali GPUs and Cortex-A CPUs. So ensure that the library contains all these the routines that you may find in models for recent convolutional networks optimized for ARM. And in this team, I look after the performance optimization, so trying to squeeze all the bits and pieces for improving the performance on ARM. But I'm also author of the TinyML cookbook, and yes, a journey that started more or less 1 year ago. To share the knowledge about this extraordinary field that is capable to do great things. Yeah, thanks a lot for sharing the cover of the book. So thanks a lot. About my background, yes, I graduated in Pisa at University of Pisa in Italy with the in software hardware co-design with an eye to computer vision and machine learning. So actually, my experience on machine learning started from there. And I have been lucky enough at ARM to work on ML since the very beginning when I joined the company, and looking at the machine learning acceleration from servers to these very tiny devices. So it's really cool. It was a very cool journey so far.
Right. So I can already see that there are a lot of comments coming in. Gian, I'm pretty sure you can see it as well. A lot of people have spotted the fact that there's a ticker going on at the bottom. So yes, there are a couple of raffles where you can get a chance to uh, win one of Gian's ebook. And there are quite a lot of people who are excited and looking forward to this talk. Thanks, Devanand. And we've got Joseph as well saying the same thing. Please feel free to add any questions that you have in the chat, and we will pick it up during the session. So let's begin with one of the most basic questions, Jian, that I have, and I'm pretty sure quite a few people have as well. Uh, what is TinyML and why TinyML?
Okay, so I have some slides, and maybe I
Oh,
can use to
okay.
explain. Can I use it?
Oh,
Perfect.
yeah, yeah,
That's
yeah, yeah.
great.
There you go.
That's great. So maybe we can use these slides to explain what is TinyML, but I don't want to start from what TinyML is. I like to start from why TinyML. So because from here we can actually explain what TinyML is. Um, why TinyML first of all? The idea is this: we want to bring intelligence to the objects around us with a focus on power consumption, and with power consumption, I mean low power consumption, data privacy, and cost. And if you think about it, these are the keywords nowadays, right? We talk a lot about sustainability, we talk a lot about data privacy, and we talk about cost, right? Because cost of living is increasing. So we want something to bring intelligence around us, keeping an eye to all of these three things. But in other terms, as I usually say, TinyML wants to make AI ubiquitous for good. So, and for good, personally, this means making positive contribution to the 17 goals of the United Nations in order to have a more sustainable world. So this is the reason we're talking about TinyML. And from this, actually, we can also talk about what TinyML is. And in this slide, I have reported what I wrote in the book in the first chapter. What is TinyML? TinyML is the set of technologies in the machine learning field and embedded system that wants to have use smart applications on these low powered devices. These devices are low power, definitely, but in order to be low power, they have some constraints. So they are limited in memory. They have reduced computation capabilities, but they are extraordinary at the same time because they can sense the physical environment through sensors and make smart decisions based on the machine learning algorithms and the data collected. In this slide, I also highlighted the important aspects in different colors because in this explanation, there are the ingredients of TinyML, which are machine learning and embedded system and low power devices. And when we talk about TinyML, so at the beginning, I said, well, I have been working on ML from the server to tiny microcontrollers. What we have here is completely different from what I personally see, but we have seen together on smartphone devices, for example. Smartphone is an edge device, but it's not a microcontroller. What does it mean? Well, I can share this. In 2017, we co-created the compute library. The problem wasn't to run machine learning because machine learning, we could run it already in 2017 because we had the RAM, we had the memory. We had only one problem. We needed to make it faster. That was the key goal. Here in TinyML, actually, embedded system and machine learning need to know each other best. Because if they don't know each other, in this field, you will not be able to run any machine learning workloads. So ML needs to know the target device, but the target device needs to know machine learning in order to expand the computational capabilities of these devices in order to be, let's say, more machine learning friendly. In terms of characteristic of low power devices, as I said, are low power. So this means they have constraints, limited memory computation capabilities. And the green one is the input. Usually these devices have one input, one or multiple inputs actually, which are the sensors. Sensors, so data will be the input for our machine learning models. That is more or less the explanation or the description of TinyML.
Great. June, can you give us an example of TinyML being executed in the real world?
Well, I don't have with me my smartwatch, but if I
Mhm.
look at the smartwatch, I'm pretty sure there are quite a lot of TinyML applications. I mean, gesture recognition or activity recognition are examples of machine learning running continuously in background on a battery-powered device. As you can imagine, well, I want my smartwatch to last at least a day. So I don't want
Yeah.
something that drains the battery. So that is TinyML. TinyML is something that can bring intelligence, like activity recognition, but at the same time wants to keep live the system for a long time. This is just one example, but of course the keyword spotting or okay, Google, for example, is another good example of TinyML application because in that case, we need to run this keyword spotting model continuously in
Mhm.
background, but we don't want to drain the battery. So it must
Yeah.
run on a low powered system in order to last as much as possible.
Great. And Jian, another thing, so while we talked about TinyML, and so who would be the right target audience to get your book and learn more from it? Would they need to have
Okay,
some prerequisites, some knowledge?
Okay, so definitely a good question. So the target audience for the book is people from, let's say, a machine learning background, so machine learning engineers or developers who are keen to learn how to develop machine learning applications for microcontrollers. In other words, probably I can also explain why I decided to write this book. So I decided to write this book because I wanted to help people with no embedded programming experience to develop machine learning applications easily with hands-on session, hands-on with practical examples.
Right.
That was the key goal. So the target developers are these people that they don't know the embedded system fully, or maybe they do not have experience, but they want to learn how to do it. So the book basically has projects to explain what embedded programming means and how to face all these challenges. At the same time, although the book is mainly oriented to this kind of developers, I would say that also embedded developers can benefit from the book, but they need at least a basic understanding of machine learning, basic understanding of TensorFlow to be able to develop the projects fully.
Perfect. So we've got our first question over here, and this is by Soy Dean, and he asks, does TinyML refer to the software on low power embedded systems, or does it refer to both hardware and software?
Okay, I put a +1 to this question. I really like it. So about this question, I can say it refers to both. Of course, in the book, I primarily talk about software, but as I said, TinyML is actually a collection of technology in software and hardware to allow machine learning on these devices.
Hmm.
In terms of software, well, when we talk about software, the hardware is fixed. So we need to squeeze everything to run it at best on these devices. On the other hand, well, the hardware needs to evolve. But how can we evolve in hardware? The only way to evolve the hardware is to keep in mind the end use cases, which are machine learning. So knowing the algorithms involved, we can evolve the hardware, keep in mind also the power consumption.
Yeah.
And I can also add this because, well, for software, the evolution of the algorithms, the evolution of models. What is happening in hardware for microcontrollers? Well, in hardware at the moment we have the micro MPUs, so something which so hardware acceleration for machine learning workloads in order to make the machine learning algorithms running in a more efficient way on these devices.
Right. So I think Amar commented a little earlier that I'm pursuing my PhD in AGI, and I can relate to Jane's talk. So I think Amar hasn't asked us, but I would like to ask on behalf of the viewers that how does AGI and TinyML relate to each other?
Oh,
Like
that's
where does one stop and the other start?
okay. So that's how can I describe the difference? For probably let me describe the difference with some examples. Okay,
Hmm.
because in both cases are battery powered, in my opinion. But if I think an edge device, well, the smartphone for me is an edge device,
Yeah.
right? But the endpoint or TinyML refers to something which is battery power but needs to last not one day, probably a bit longer, or
Mm.
something smaller than that. So definitely, I think the distinction is between edge devices and endpoint. Endpoint is the tiniest devices where, like microcontrollers, where they have important constraints on computation capabilities in particular. Edge devices, let's say, they have some limitations. They are battery power, but definitely not like these endpoint devices. Are
Okay.
definitely capable of doing great things, the edge devices. If I look at my
Yeah.
smartphone.
True. So the other thing, so there are more queries. I'm really glad. Thank you everyone for starting to share your queries in. I think we've answered this one,
Yeah.
but yeah, Aloin has a query where he asks, does TinyML run on containers?
On containers, what do we mean exactly here? So
Uh, yeah, Aloin, it would be best if you describe it. Am I right to assume that he's talking about Docker containers?
yeah,
Um,
if I'm
yeah,
talking about that,
let's assume he's talking
let's
about that until
okay.
yeah.
Well, TinyML. primarily runs on devices which are like microcontrollers, but not just microcontrollers. Let's say embedded systems which are low power by nature. I like to describe it this way. That is I would say TinyML is primarily for um, devices like in microcontrollers, which have the power consumption at the heart of the hardware. That is where TinyML is executed.
Right. So not Kubernetes and Docker
No.
then. Okay. Yeah, and Amar has contributed to that as well. Easy example. Edge devices, Raspberry Pi, TinyML is Raspberry Pi Pico.
That's
So
correct.
Frank has a question. Do you have use cases of using TinyML in production manufacturing at scale?
Okay, so not personally, because I'm on a different industry. I'm more on enabling the use cases rather than working directly on the use cases. But
Hmm.
I'm aware that this TinyML is actually, I mean, is trying to find space also in automation and industries as well. And there was an interesting definition of Alan Alistair recently on TinyML. I joined him in a panel, and he described TinyML with a single sentence, saying, "Well, TinyML is a layer above the sensors." Well, that one, perfect. Thanks a lot.
You're
Level
welcome.
of computing on top of sensors that allows smartness in a minimal intrusive way. What does it mean? It means that TinyML will be there for sure, in addition to our sensors. So this means that we will have in production manufacturing, for instance, use cases with another thing without requiring necessarily internet connection. That is, I don't have it, as I said, the perfect use case is mine because I come from a different background, but I'm pretty sure that it's gonna exist anyway.
Yeah. There are quite a lot of applications that you've prepared to show us,
Yeah,
Gian. Is this the right time? Should I pop that up to just showcase the
go
applications
ahead.
that you have?
Yeah. So yeah, in particular for the production manufacturing at the scale, probably not, but I can tell you that well, TinyML is already around us. I mentioned smartwatches. I mentioned keyword spotting with the smart assistant. Also, our smartphones. I mean, we interact with the voice with the smartphones, so there are TinyML applications also for
Hmm.
knowing the activity we're doing. VR, AR to know the orientation of a screen, and drones. Well, drones is another device where you have a battery and you need to run computer vision application it, and you want something that doesn't drain the battery. Although there probably the battery is more stressed by the motors rather than the computing system. Next slide. Probably I can report other TinyML application. Yeah, this is more because when I mentioned the previous TinyML applications, it's primarily on single task, single device. However, TinyML can live in a context of different devices, like in an industry, manufacturing, for example. And in the scenario I reported here, I know, for example, TinyML is used for detecting fires and preventing that the fire is from spreading over large area.
Hmm.
Well, why you need TinyML? Well, in that place, probably you don't have power from the main with high probability. You need a battery. Well, solar panel can be something that you can use, but at the same time, it costs. As I mentioned at the beginning, we want to keep control of the cost. So we want to have, let's say, a device which is capable to run for a long time on a battery system without draining the battery so quickly. And that is another use case: fire detection and trying in order to prevent fires from spreading. Agriculture, I know people there was sorry, there were some interesting papers about TinyML in Africa, for instance, for improving agriculture efficiency. There are quite a lot of use cases. We talk about the efficiency of resource watering and other similar things. Well, TinyML finds its natural home in these use cases because,
Mm,
of course, I will be all battery power and they will need to live as long as possible.
yeah, truly sustainable, as you mentioned, Ian, in the long run. We've
Yes.
got an interesting query on YouTube, so I would like to pop that up first. There's Johnny who inquires, uh, TensorFlow Lite has support for mobile edge devices, and TensorFlow Lite Micro has support for small MCUs. Machine learning for edge device still got challenging in performance. What is that TinyML can be better at?
Okay. Let's say, well, challenging performance, of course, if you are comparing with a server use case, or use cases, well, probably you don't have a server in your pocket because otherwise it's not gonna survive for more than 1 minute. Our smartphones. But I can tell you that definitely are more powerful in terms of performance, our smartphones, and now they are capable to do great things. They have powerful CPUs, but if you're not happy, we also have a powerful GPU with extraordinary capabilities. Some smartphones that also have powerful NPUs, so there are a lot of hardware there. On TinyML, well, this is a scenario where you have a powerful CPU, you don't have a GPU, you have probably a micro NPU, but not necessarily. So here you need to is a more constrained device. And why I'm saying this? Well, here the key point is power consumption. We cannot put everything there because otherwise we destroy the device in terms of efficiency for the power consumption. Remember that it's hardware, so whatever it's a device where, sorry, everything is done in silicon. So everything, whatever we put in silicon, must be carefully considered. I can give an example. Floating point unit on these devices, well, with high probability will not be there because we want to keep the power consumption at minimum. So what is TinyML can be better? I can say it can be better if we find models which are highly tuned for these constrained devices, because otherwise we will not be able to run anything. Here is not machine learning. This is machine learning plus the embedded device. On the edge device, well, we keep an eye to the target device, but we try to deploy models that are, let's say, trained on the server, and we try to execute straight away on the edge devices without, let's say, tweaking the model or something like that, or a bit of tweaking, maybe quantization and other things. But in TinyML is completely different. It's a more constrained, and we need to keep an eye to the architecture for sure. So
Yeah.
it's more challenged.
Yeah, Yusuf has described it quite well in a small sentence that it is, as you said, useful for memory constraint and low power device.
Yeah.
Thanks for that, Yusuf, and thanks for the question, Johnny. Um, so it also in like is preparing for a reference to well a research on agri-tech, and he was wondering if there are instances where TinyML is actually deployed in agricultural industry.
I know someone in our Discord server because for the TinyML cookbook, we have also a Discord
Hmm.
server. Yes, great, Vincent. I'm super happy. Great. And I know someone shared that he had quite a lot of interesting use cases for agriculture. Maybe we can put in touch them because these are the experts. I don't I'm not the best person in terms of use cases, but there are brilliant people around the world that are working on exciting and interesting stuff. So that is the and absolutely is something that we can do, that we can put in touch.
Yeah. Yeah, so it you could probably, I hope I'm saying your name right. You can join this Discord server. In case you are one of the people who have access to the book, these Discord links are within the book as well. After, I think at the end of each and every chapter, So yeah, you can probably find the Discord server link over there. So before we go ahead, I think we are at the halfway mark now. Let us do the first raffle and then we can do another
Let's
raffle at
go.
the end. So yeah, people, if you have any more questions, please feel free to add them uh, in the chat. I'll just share my screen and we can do the first raffle. I hope I have started the raffle. Oh yeah, I have started the raffle. I'm happy because people would have killed me. They wasted all their comments. Before we go ahead with that, let me show something interesting to people. Actually, let me come back to that. So this is the raffle first. Can you see my raffle screen, Jian?
Yes, I can.
Okay, let's hit draw. Let's see who wins the first ebook. We've got 20 entries now. Someone just quickly typed it in. So John McCook is the first winner. Congratulations, John.
Congratulations. Yeah, definitely.
Yeah, if you can just get in touch with me, drop me a message on LinkedIn, DM me your email address, and I will get Jian's ebook shared with you. And while I'm sharing my screen, I would so anyone who does not win an e-copy, please don't be disheartened. Uh, we have something interesting going on until the 10th of June. So as you see, this is one of our new websites. This is a new store page. Until 10th of June, we've got a $10 campaign going on where all ebooks and videos are only for $10. So you can just head on to pact.com. It's simple, just like our name, PACKT.com. It will take you here and you can find all our books are over here and all ebooks are just $10. Well, I'm in the UK. That's the reason why it's reading as £10. So yeah, so you can just head over to our website and you can download any and as many as possible books as you like. Jian's book is also a part of it, and you can buy any other book as you want. And we'll do another raffle shortly. Before we go ahead with any other question, Kiselea asked a question a while ago and I kept it for later. What are the challenges on TinyML that you have faced here?
That's a good question. Um, okay. Let me put this. Let me use the TinyML cookbook as an example. So,
Mhm.
what is the biggest chapter or the most challenged chapter of TinyML cookbook? Which is more or less the same question. I can tell you that the biggest challenge was basically to try to adapt models that have been trained on the server and probably executed on smartphones to run also on microcontrollers because of the limited memory. Chapter 5, sorry, personally was probably the most challenged chapter. At the same time, one of the most interesting at the same time. The goal of chapter 5 was to develop an indoor scene recognition. So, recognizing, for instance, a kitchen from a bathroom. And I use a pre-trained mobile net with transfer learning to on an Arduino Nano, which is a microcontroller. As you can imagine, well, MobileNet, although we can take one of the smallest MobileNet version, well, Mobile has not been, let's say, trained considering microcontrollers. So I had to, let's say, tweak or adapt the model a bit in order to fit the constraint we had on the device. What kind of constraints? Well, we're talking about a device with a megabyte of hard drive ROM and hundred of kilobytes of RAM. But the other challenge was this. It's not just about tiny machine learning, because there is another challenge that I also describe in the book. When we think about TinyML, we always think about machine learning is our biggest problem in the world. Well, probably it is, but if you consider a camera, and if you consider a model, well, the camera acquires the frame with a fixed resolution and color format. The model accepts as a different, usually a different resolution, a different color format, different data type. Well, we need to convert the camera frame to the input of the model. If you consider an edge device, well, probably I can use one of the libraries where we can call 3, 4 different functions consecutively, and we can simply prepare the stage. On microcontrollers, sometimes this is not possible because if you use two different functions fully, you saturate the memory, so you don't have enough memory to convert to do this full conversion. That is the reason, and this one was another challenge I faced, was to convert the camera frame to the input of the model using a fusion approach. So gradually applying all the techniques, pixel by pixel, all the functions like resize, cropping, color space conversion, pixel by pixel, in order to keep a minimum the memory utilization. That is likely different from what for instance, we can see on OpenCV or on other libraries. You call the function and returns an output. There, you need to run the function on a sub-region of your input and return a sub-region. On that sub-region, you perform another operation and so on in order to keep it a minimum. Those were the biggest challenges definitely I had to face for the TinyML cookbook. But it
Thanks
was
for that.
interesting at the same time because I really had fun to try to explain how to solve this problem.
Yeah. Thanks for asking that question, Kesile. Just before we move ahead, I would just like to quickly answer some hygiene questions. The link to the Discord server is already in the chat. It's just about 1, 2, 3, 4, 5 comments about this comment of yours. In in case Vincent is still watching, Vincent, can you please add the link for the Discord server again to the chat and make it easy for Soviet to join the Discord server? Alternatively, Vincent, can you please add Soviet on your LinkedIn, and that would help. Uh, Jaspreet had a question. I joined now. Please, can you explain the main points? Jaspreet, in case you've missed anything, don't worry about it. The recording will still be available on LinkedIn and YouTube. You can just go on Pact YouTube and you can watch it there later. Thanks. Someone has added the Discord server link, so if you can see this, you can just go ahead and join it. Sorry for that, Jian. I just had to quickly answer all these hygiene questions.
No problem.
Rifty has an amazing question. Is TinyML relatable to TensorFlow? And let's start how and how.
So, okay, relatable means that can TinyML be deployed with TensorFlow? The answer, if this is the question, the answer is yes. In the TinyML cookbook, I presented TensorFlow Lite for microcontrollers as the suitable solution for deploying TinyML models on microcontrollers.
Great. So it has a question again. So I'm assuming you found the link on Discord server link. So he's assuming that we use C and Python in the book. Have you run TinyML test using Rust? I understand that
No.
is efficient and low power language.
Yeah, no, I didn't use it. I primarily use C, C++, and a bit of Python. But I need to be honest, primarily C, C++, and in my, let's say, daily job, I also use a bit of assembly for having a more fun. Why assembly? Sometimes you need to squeeze every bit to get the performance, and you need to use assembly to get the best performance. That was the case for the compute library. In the compute library, some routines are implemented in assembly, and the same for TinyML. In this case, it's a different library, CMSysNN, but these were the primary the three main programming languages used.
Right. Are there any challenges for using Rust on TinyML, or people just don't use it in general?
Well, I haven't seen use it a lot. I know people that were trying, but for me, it's honestly difficult to answer this question. I can also because most of the people have an embedded programming background, so I'm primarily hardware engineers. They're writing firmware, so they're more, let's say, oriented to C and a bit of C++.
Yeah.
That is the trend I've seen so far, but I'm pretty sure probably it's going to change probably in the future.
All right. Abhijit has quite an open-ended question. What machine learning, deep learning algorithms TinyML uses? And he has a follow-up question also is, Let's cover one question at a time. So,
Okay.
what algorithms does it use?
Okay, so for deep learning, I would say convolutional networks for sure are the ones we can use for TinyML, but are not the only ones, because also simple fully connected networks can be used and used with success on these devices. Why I'm saying this, there is a chapter in the TinyML cookbook which is about creating building a smart remote. So in short, you use your microcontroller to change the videos on YouTube. And in that case, I use a very simple, fully connected neural networks plus feature extraction. If you
Right.
wonder why the reason is simple. There's techniques which are still they still produce good results and they work and they bring good performance. So that is the only reasons, because some old techniques are still used also for TinyML, and they provide also a decent performance, they decent results.
Right. So,
Um, yeah, go ahead.
yeah, so I just wanted to ask a follow-up question. So, in the broader
Yeah.
perspective, is it supervised, unsupervised, or reinforcement learning the
Okay,
algorithms?
that's nice. That a good question. Well, definitely you can do almost all. I say almost because definitely supervised is something covered. I'll go directly to the reinforcement learning and supervised. I know people working on that about reinforcement learning. I know there were some interesting use cases in TinyML. I can also give one for improving communication efficiency. So in the TinyML world, I say most of the time you don't use internet connection, but there are scenarios like, let's say, agriculture, where you have a lot of devices deployed on the field, but these devices need to communicate to each other, because what is important is that a global understanding of the physical quantities on the field. Also, they need to communicate to transmit the knowledge from one point to the server. So they need to create like a mesh network or another type of networks to propagate this information to the server. There was an interesting use case, I believe 3 4 years ago, where they used reinforcement learning to basically predict the best node to communicate that information. So it's something that the device continuously learned to decide what node could be the best option to deliver that information, keeping in mind also the power consumption.
Right. So I don't think so there are any more questions. So if people have more questions, please feel free to add them. I'll get another question that I have answered.
Yeah.
So, Chin, where do you see TinyML going in the future? Like a few years down the line, what do you feel TinyML would look like?
Okay. I definitely can say that the hardware, the processor will be more machine learning friendly. And with this, I mean more power friendly to machine learning workloads, because we will have micro NPU capabilities and neural processing unit capabilities in hardware to accelerate machine learning workloads. That probably is going to unlock use cases which at the moment are a big challenge. Um, there are still in use cases like, for instance, in audio, where there are some important constraints on the memory requirements.
Hmm.
But if you ask me where we are going in what direction, probably I'll link my answer to the description of TinyML is one level above the sensors. If now we are in a position to say, to build, let's say, a water leak detector, well, probably with TinyML, we will be able to predict if we're going to have a water leak, which is much better, because
Yeah.
a water leak actually detector is great, but this means that the damage is already there.
Yeah.
If I'm able to have a smarter solution, probably in the future we will be able to predict the leak and avoid the damage in the first instance. That
Right.
is
So
whereas,
it will get more proactive than reactive, is what you're saying.
yeah,
So,
because it's gonna be an addition to our sensors. Now sensors
right.
are great to detect, but what if we try to predict in order to prevent the damage?
Right. And if I'm not wrong, I think that's where reinforcement learning plays quite an important part. It learns
Yeah.
from itself and then it will be able to predict in the future. So do TinyML devices learn from each other?
Okay. Well, you can use federated learning. I know people already working at University of Pisa, for example, they're working on federated learning, so collecting the knowledge from different devices, trying to communicate. Well, it's possible, um, but we need also to understand that we try to keep a minimum the communication between nodes.
Yeah.
So we need to transmit only when is necessary. Uh, I can see primarily federated learning in terms of building and complex knowledge all together, uh, and the server or the edge devices will do the rest.
Perfect. Thanks a lot for that, Jian. I think we're done with all the questions. Uh, let's quickly do the last raffle.
Yeah.
And before the last raffle, I'll inform people again that don't be disheartened in case you don't win. I'll just share my entire screen and I can show them. So let me share my entire screen and just show them. So there is a $10 campaign live on the Pact website. As you can see, it's pact.com. You can directly go onto the website. It's one of our new product stores. All ebooks and videos are available over here for $10. You can download any and as many books that as you would like, and it would just be $10 per ebook. Now, finally, let's do the last draw. The first winner that we had was John McCook. John McCook, please get in touch with me, DM me, and I will ensure that the book ebook gets shared with you. And a final draw, in case John gets drawn, I will do a redraw, so don't worry about that. But we have quite a lot of entries today. Mohammed, Ayman, Akid. I think that's Bilal in the end. Congratulations, Mohammed. In case you're still
Congratulations.
seeing, please get in touch with me, DM me, and I will ensure that you get access to your ebook as well. So, thanks everyone. And I've removed this. Okay. Oh, and so it as a final comment. I think federated learning with TinyML is problematic based on your earlier comment that these devices typically do not have connectivity. Yeah.
Yeah, indeed. What I was saying is, well, there are, let's say, research works. As I
Hmm.
said, I know at University of Pisa, for instance, they're working on these, or using federated learning. But yes, we need to keep a minimum of the communication if we don't want to drain the battery.
Hmm.
So definitely, but another, that is the biggest constraint at the moment. Probably, if you want, I can share a couple of slides
Yeah.
about these.
Yeah. I'll
Probably I
just add
can.
it.
Yeah.
Sorry, go on.
No, no. Okay, that's perfect. So let me go to. Yes, so this one. So this is a distinction of where the TinyML application can live. So this is okay. On the left hand side, there is the TinyML application, which is living in a centralized system. In this case, TinyML does not need to communicate with other devices. It's probably part of other systems, and I can describe this as an interrupt, an extra interrupt, like the OK Google, for example. And these applications are, for instance, used for enable or trigger any or more power hungry applications, for example. But there are cases where TinyML may live on system with other devices, and this is called wireless sensor network. And in this case, like in the forest or in agriculture, these devices need to communicate between them in order to either propagate the information to the server or to aggregate the results. So there
Hmm.
are these two distinctions for TinyML. So decentralized TinyML applications and a distributed TinyML applications.
Great. All right, so that covers it all. So before we wrap up, Jian, if people have any more queries and if they were not able to attend this session or probably we did not cover those questions, uh, what is the best place to get in touch with you and how can they get their questions answered?
Absolutely on LinkedIn. So if they want, they can add me on LinkedIn. They can drop me messages, and I try to answer as soon as possible. I know people recent were in touch about for the book. I mean, sharing the opinions, ideas, suggestion, which was great. I mean, having ideas for the book, it's absolutely amazing. And also on Discord. But I would say LinkedIn and Discord at the moment are the two main places where to be in touch.
Perfect. All right. Thanks a lot for that, Jian. So thank you everyone who attended the session, and thanks for all the questions. Congratulations to John McCook, and I believe it was Mohammed who won the second one. So please get in touch with me, and I will get your e-copy arranged for you. Thank you, everyone. Have a great day.
Yeah, thanks a lot,
Bye.
everyone, for attending. Bye bye.